So today we are working with special right triangles. This is lesson 5.1e. So you've seen these special right triangles before in geometry and also algebra 2. So normally when you saw these, this is a 30, 60, 90 triangle, and this is a 45, 45, 90 triangle. Normally it would say n, 2n, and n square root 3. Then this one would say n, and n square root 2. The ones we're working with today, actually, we're just going to have ones, like actual numbers with no ends on them. So I do want you to notice that the shortest side on all these triangles is a 1. So 1 is the shortest side. The hypotenuse here is 2. We call this the long leg is square root 3. And then these two short sides are 1, and that hypotenuse is square root 2. Another interesting thing to point out on these is how you can tell which angle goes where and which number goes where. So what happens with angles is, I'm going to use my pens to demonstrate, is if I have, let me zoom way out here. If I've got two rays and I want to make an angle out of them, well, what I would do is I would start opening them up, right? But as I open them wider and wider and make a bigger and bigger angle, the side that's being created over here is getting longer and longer. So larger angles create longer sides, smaller angles create shorter sides, but they're the sides that are opposite of them, across from them. So when I look here on these special right triangles, well, if I can pick out the shortest side, so the shortest side is this 30. And if I look at the side, or sorry, the smallest angle is 30. If I look at the side opposite of that, we get the shortest side of 1. Then if I look at the largest angle is this 90-degree angle right here. And the side opposite of that is our longest side, the hypotenuse. And then the two that I haven't highlighted are the middle. So 60 is the middle angle, square root of 3 is the middle side. So we've got a short leg, a long leg, and a hypotenuse. Same thing happens here. It's no coincidence that these two angles are equal, and therefore these two sides are equal because they create the same size gap across from them. So those are both just 1. And then here we've got a square root of 2. All right, so what we are going to be doing today is basically trying to memorize these special right triangles. You'll see on the homework, the whole top section is just basically rewriting these two triangles over and over and over again. But that's because we want you to get those memorized. Next week, about 3 lessons ahead of this one, you're going to be learning a really complicated thing that involves writing these triangles a bunch of times. And if you've already have them memorized, it's going to make your life about 10 times easier than if you don't have them memorized. So this might not seem that hard, but it's worth our time. All right, so we need to find the exact value of each of these trigonometric functions using these special right triangles. So you'll see that all the angles that they give us here are all the angles that we see up here in these special right triangles. So a 60-degree angle would be part of our 30, 60, 90 triangle. 45-degree angle would be part of the 45, 45, 90 triangle, and same with this one. So because I see a 60-degree angle here, I'm going to start by just sketching out my 30, 60, 90 triangle. And you can draw it kind of facing any direction you want, as long as you get all the labels in the right place. So if I put the 90-degree angle here, that means my longest side of 2 should be across from that. If I put my smallest angle of 30 here, then opposite of that should be my shortest side. And then the last one, the middle, are the 60 and the square root of 3. So we're asked to find the secant of 60 degrees. Well, one thing I know right off the bat is this is going to be my focus angle, the 60 degrees. So I'm going to label my sides real quick with the opposite, adjacent, and hypotenuse from that perspective. So opposite, hypotenuse, and adjacent. Okay. So secant. Secant is the partner of cosine. If we look back a couple of pages, so cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. So when I'm doing this problem here, I just need to remember that I should be using hypotenuse over adjacent. So looking at my diagram, it looks like I labeled the hypotenuse on the side length of 2, and the adjacent is on the side length of 1. So there we go. Secant of 60 is 2 over 1. You could always check your answers on these two. This is what we did a couple lessons ago. So if I do 1 divided by cosine of 60, if I did it right, I should get 2. And I did. All right. Let's try the tangent problem. So we've got tangent of 45 degrees. So 1, 1, and square root 2. So tangent is opposite over adjacent. And we asked to find the tangent of 45, and it might be a little confusing because there's two 45-degree angles. But the thing is, we'll get the same answer no matter which one we pick. If I choose this as my focus angle, opposite over adjacent would be 1 over 1. If I choose this as my focus angle, opposite over adjacent would still be 1 over 1. So tangent of 45 is 1 over 1. And again, you can check that with your calculator. Tangent of 45 degrees is 1. And number 3. So cosine of 45 degrees. So notice I'm drawing these for every problem. And the reason why is because the priority here is that you memorize these. So the more often you can draw them, the better, because it's just going to lock it into your brain. So cosine is adjacent over hypotenuse. So again, it doesn't matter which 45-degree angle I use, but if, let's say I use this one, the adjacent is 1, hypotenuse is square root of 2. Now, on this problem, we are faced with a problem that we have to simplify. So the square root of 2 being in the denominator is a no-no. We can't have square roots in the denominator. We talked about that, I think, the last lesson. No. Let's see, that would have been in 5.1a, we talked about that. So what we want to do is we want to rationalize our denominator. And the way we do that is we just multiply the top and bottom by the square root of 2. So 1 times the square root of 2 is the square root of 2. But the square root of 2 times itself actually just simplifies to 2. So this answer is square root of 2 over 2. I'm just going to do a little side work to explain why that equals 2. So the square root of 2 by itself times itself would equal the square root of 4. And the square root of 4 is 2. That's how we end up with 2. All right, now let's go ahead and move on to the bottom half of this assignment. This one's a little trickier, I think. So here they've got cotangent of an unknown angle equals the square root of 3, and we have to figure out what the angle is. So square root of 3 is a number that I see on my 30, 60, 90 triangle. So I'm going to go ahead and draw that. Okay. So they're asking us for the cotangent of the square root of 3. So cotangent is the partner of tangent. It's the reciprocal of tangent. So I know tangent's opposite over adjacent. So that means this one is adjacent over opposite. And the answer is square root of 3. So it kind of makes sense to me that this might be square root of 3 over 1, because that is what is equal to the square root of 3. So I'm going to look at my triangle over here. And it looks like the square root of 3 is here. It looks like 1 is here. But I want the opposite side to be 1. So when I decide which angle I think is the focus angle, I'm going to go to the 1 and find which side is opposite of 1. And it's this 30-degree angle right here that's opposite of 1. So that means the adjacent side should be square root of 3, and that would also make sense. The square root of 3 is adjacent to this 30-degree angle. So it looks like the 30-degree angle is the one that gives us a cotangent that is equal to the square root of 3. So my answer is going to be 30 degrees. Let's try number 5. So number 5, we are given sine of an unknown angle is the square root of 2 over 2. But it's a little confusing because here I don't have any 2's on my 45, 45, 90. That one is the one that has a square root of 2, but there's no 2 here. There is a 2 over here, but there's no square root of 2. So it's a little maybe confusing. But then I'm going to look back here at the work we did on number 3, where the answer I got was square root of 2 over 2, but that's actually the answer I got after I rationalized my denominator. That answer started off as 1 over the square root of 2. So I'm going to rewrite this as 1 over the square root of 2. And when I do that, it actually matches my 45, 45, 90 pretty well because I've got 1's here and I've got a square root of 2 here. So I'm going to go ahead and draw 45, 45, 90. And that's 1, 1, and square root 2. So I need to figure out which angle has a sine ratio of 1 over the square root of 2. Well, sine is opposite over hypotenuse. And so the opposite has to be 1 and the hypotenuse has to be square root of 2. Well, hypotenuse is the square root of 2. And because it's a 45, 45, 90, both of them have an opposite side of 1. So the answer to this is just going to be 45 degrees. From either angle, I get 1 over the square root of 2 versus 1 over the square root of 2. So either of those angles works. And lastly, we've got cosecant of theta is equal to 2 square root 3 over 3. So cosecant is the partner of sine. Sine is opposite over hypotenuse. So I know this one's got to be hypotenuse over opposite. But once again, we have an answer that's already been rationalized. So it probably would have started with a square root in the bottom because it looks like the same numbers that I see up here with my 30, 60, 90, except there's no 3 up here. There's a 1, there's a 2, and there's a square root of 3, but there's no actual 3. So I'm going to actually kind of de-rationalize this one, and it would turn into 2 over the square root of 3. So it kind of follows the same pattern that we saw over here with number 5, where the square root on the top actually goes on the bottom, and then you can just take that square root off of the top. So 2 square root of 3 is what we're looking for. So I'm going to draw my 30, 60, 90. All of my 30, 60, 90s look different, and that is okay as long as I have like one side that's a shorter side than the other. So this is 1, this is 2, this is square root 3. So I want 2 over the square root of 3. So here's the 2, here's the square root of 3, and I'm going for hypotenuse over opposite. So I can agree that 2 is definitely the hypotenuse, but I need the square root of 3 to be the opposite side. So opposite of square root of 3 is the 60-degree angle right here. So I'm going to say for this problem, theta equals 60 degrees. Okay, that is it for today. This homework assignment, most of it looks like the top half right here. As a matter of fact, the whole beginning half of the assignment is actually just drawing these triangles a bunch of times. And then when you get to the bottom half of the assignment, it's more like this section. This section of the notes does not come up in this part of the assignment, but it will come up in another assignment.